one of the things that came up in the report is that only 17% of organizations have automated scanning and governance to actually catch AI-specific risks, things like serialization issues or pickling vulnerabilities, hallucinated dependencies. So for the engineers who are joining us today, can you explain why some teams might be blind to these threats and what makes AI-related dependencies something new for teams to consider?
I think blindness is probably quite a strong word. I think I would hope that nobody's deliberately making unsafe choices in software, but the point is you don't know what you don't know. So it's really about exposing that. I think many teams have less visibility because their tooling was built for things like knowing packages of problems, CVEs, and prior workflows. And it's not quite that easy anymore with the introduction of AI-driven software development, just because of the speed, the scale, the complexity, and also where you're getting these from. So something like a hallucinated dependency that introduces a bad package, it might not have a CVE, so there might not be intelligence that says that actually this is a problem. If you've got something that the AI says import this package, there may be no history of that. There may be no history associated with the package that someone might go out there and exploit it by creating it, and now you're consuming it. You might be the only person in the world or your team trying to use it. So it may not even exist yesterday. But if an agent suggests it and an attacker goes off and then actually creates that, they've got potentially access to your systems. Your build will just accept that, run it, install it quite happily, and then this is where you get things like it wasn't a hallucinated dependency, but if you think about the impact of something like Axios, or you're running something in your system, it's got access to the systems, and that's not a good thing. AI models are another example of that, where they're a different version but of the same problem. So a model, as people utilize it, it's about weightings, it's about how you get from A to B to decide something for generating an LLM's GPT. But it's not just a big innocent blob of mathematics. Like you would just say, it's just weights, right? Depending upon the format and the way that you actually load those, they can carry different types of risks. You said one earlier on, Megan, is like deserialization, where you just don't understand the runtime behavior of the model. If you have a model in your systems and it gets executed and a third party controls that, with deserialization risks, for example, something like Python pickle, you've got the potential to execute arbitrary code controlled by a third party in your system. So the rule just has to be super boring and strict, that actually you need automated governance. And it's just that if it crosses a boundary from the outside world, if it comes from somewhere else, then you need to combine things like identity and metadata, all the boring but useful stuff, provenance, and a policy system to make a decision that actually this is something you can trust. And that kind of thing will help make AI usable in serious environments.